Well, I needed a heatsink for to put the MOSFETs on, which arrived in the mail today. And I remembered I had this old Marantz 500 watt amplifier which doesn't work anymore, just kicking around, and I thought, I know it's got a heatsink in it, I'll pull that out. And when I was taking it apart, I realized that there are four fairly beefy bipolar output transistors in this thing. And so I think what I'm going to do first, before I do the MOSFET version of the Slayer exciter, is I'm going to pull one of these transistors over here, one of the NPN ones. Let's get in a bit there. Test it, make sure it works, and then bolt it back on the heatsink and wire that up to my little test circuit and see if we can't get a little bit more current. I don't really care if I blow up these transistors, but I will put them on the heatsink first. So I think I'm going to try that, and then we'll move on from there and use one of the MOSFETs that I bought today and see if we can't sling a bit more power through the primary. So just before I get all gung-ho and put this transistor on a heatsink and wire it up, I thought I'd just plug it in the board. So it's I put some tails on it and stuck it in the board that the little 2N2222 was in, and I've wound the power supply current limit up to 0.4 of an amp, and we're going to turn it on, see if the green LED comes on, which is the one that indicates that it's oscillating. Ooh, it does. And let me grab the light bulb and see what we got here. Oh yeah. So it definitely works. So I'm going to turn that off, and I'll put this transistor here. It's not hot. It's warm, but no shouting today. So I'm going to put that on the heatsink and bring it back out here, and then we're going to run it with the current limit much higher and see what happens. So I've got the power supply set to 0.4 of an amp, 12 volts. I'm just going to turn it on. I've got the new transistor, big NPN power transistor, sitting on a heatsink. We'll turn it on. Green light's on, so it's oscillating. It's still in current limit. You can see it's pulled the 12 volts down to 7.5. So I'm going to turn it off, wind the current limit up a bit more. Yeah, no, you want me to put my finger on that and see if it's hot, don't you? Oh, stone cold. Okay, so let's go up a couple of hundred milliamps. Alright, well, we'll live dangerously and go up to 0.6 of an amp. Alright, we're still in current limit. Oh, it lights up much further away now. I'm still not seeing any plasma discharge from this wire I've got dangling out of the top here. I was really hoping to see some little purple flames, but I think we've got a bit more current to go yet. Let's wind it up a bit more. See if it's hot. It's doing very nicely. Alright, so I was about to say we've got nothing to lose here, so we'll... What's the wrong thingamy? Let's go up to an amp. Turn it on. Alright, so it's not in current limit now, so it's running about 8 watts. Whoa! Came up quickly. Field density is really high down here. But we still don't have any plasma coming out of the end. So we're running 12 volts into this primary of 3 turns, and there's about 1200 turns on here, so it's about a 400 to 1 increase in voltage. And we're running probably 20 volts RMS on here, given that it's spiking around quite a bit. I have to put the scope on it to see. So, what did I say? So, 400 times, say, 20 is 800, about 8,000 volts. So it's not really enough. I mean, to get good plasma discharge out here, we want like 50,000 volts or more. So one of the things we can do is reduce the number of primary turns. I'm just going to fiddle with this for a minute. Let's try my big hat. Nothing that'll actually make any difference. But we're back in current limit again now. Oh, comes on much further away. So that's more like the behavior I was really expecting. Let's live dangerously and hold a piece of wire. Now I'm still not seeing anything. But we are in current limit again, so is it hot, Nigel? I don't know. Let's put the finger I damaged yesterday on here. No, not even warm. So I'm going to wind the current limit up to 2 amps. I know you're saying, why are you bothering? Just go the whole way. Alright, well that's it running flat out right now. Now it's coming on way down here. Or up here. So I put all this effort into making these nice rounded surfaces so that we don't generate, small radiuses generate high field density, so you get plasma breakdown from the breakdown of the air. So I'm putting this sharp little point of wire on the top to try to deliberately provoke it a bit. And we still don't see anything, but now the light bulb comes on. Has it made any difference to it? I don't really think so. I can't hear any hissing either, which is usually what you hear when the head is breaking down. You get a sort of noise. Now I'm wearing my safety flip-flops, so one thing that we can try, if we want to live dangerously, yeah, let's live dangerously, Nigel. There's nothing hot to touch. This is still, yeah, it's not even warm, that's good. And stick a bit of wire in the power supply. It's so much easier to do with the lights on. As many people have said in my life, why do it have to be so difficult all the time? I don't know. It's got something to do with being English. Alright, so I've stuck this in the low voltage side. No, alright, we're going to pause here. And turn the lights back on. attached a bit of wire to the low voltage terminal, and we'll bring it up towards this and see if we get, I can't see what I'm doing. Absolutely, oh, it's not turned on, you idiot. So it's running, and I've got this ground wire here, which I'm going to bring up to. Oh yes, that's what we want. That's what we're looking for. Because doing this in the dark is great fun. I could see where that wire was. So that's about 1/4 of an inch gap. Oh, that's a nice plasma. So that was about 1/4 of an inch it was jumping, so it takes about 25,000 volts per inch. So we're in the range of probably around 5,000 volts, something like that. So I've taken the wire off the top, so I've just got the top hat here. I'm going to turn this back on again, and I'm going to bring my, you can't see anything in here, so I'm going to bring my ground wire up to the top here in the dark, which is always fun. I can see a nice little purple flame dancing out of there. Let me see if I can get a bit closer with the camera. Okay, so I'm a bit closer now. Hopefully you can see the little arc there and hear that squeak over the sound of my laundry going on behind the garage door there. Now, since we haven't set fire to anything yet, and we've maxed out at just under an amp at 12 volts, it's time to wind the voltage up a bit. So let's go up to, don't be annoying. Let's go up to 20 volts, 2 amps. Something's going to blow up or catch fire eventually, or I'm going to get electrocuted, but we'll keep going. Alright, so it's gone into current limit. What I need is some light with my light bulb. attach the ground wire to the light bulb. Well, it comes on over here now. I don't know if you can hear, but it's hissing at me. Oh, so the other thing is that, so the light bulb's on because the current's going down through me and through my special insulated flip-flops into my concrete floor. But if I bring this sharp ground wire up to here, you'll see that once it arcs, well, if you can see, but it's reducing the field when it gets close, and once it starts arcing, the light goes out because there just isn't any voltage, there isn't a high voltage field near the light bulb anymore. I'm getting all excited about winding it up to about 50 volts in a minute. I'm going to put my little pointy stick back on top. See if we got anything there. Oh, now we got something going. I can't see what I'm doing. I'm going to get electrocuted in a minute. Yeah, now we've got a little plasma discharge coming out at the end of the wire on the top all by itself. And I can back away from it. And it'll stay going. I'm going to wind the voltage up a bit more and we'll get the camera in a bit closer and we'll see if see what we can see. Alright, so this is as high as we can go with this power supply. So I'm going to try to get the camera in a bit closer without frying my nice camera. Let's see. Oh, we're in current limit. Maybe I should wind that up again. Let's have a look. Yeah, there's a little flame. Let's bump the current limit up a bit more. Yeah, I know what you're thinking. You're thinking you haven't put your fingers on that thing to see if it's hot recently. Alright, well, I don't know if you could hear that, but there was hissing coming from around the power supply, so I'm not very keen on frying my power supply, so I've put my, oh, bad news. Well, that was pretty exciting, but the green light went out, which means that we fried the transistor just as it was getting interesting. Time to move on to the MOSFETs. This thing's probably got a breakdown voltage of 60-70 volts, and we'd probably be beating it way higher than that. The MOSFETs that I have are 1200 volts at 10 amps and much lower on resistance, so I think it's time to move on up. So that's the transistor I just fried in the same circuit as we were using yesterday, and just for the record we were running at 30 volts, which is the maximum for this power supply, and a current limit of 4 amps. And actually I think it was at the current limit, so we're talking about probably 100 watts, something like that, going through this transistor. And did it get hot? Nah, it's vaguely warm, but that's all. So what probably happened here is that the high voltage from the primary zapped it. Or not. What do we notice, Nigel? We notice that the power wire is not connected to the primary anymore. Ooh. Okay, so I've noticed that one of the wires had come off the primary, so I haven't fried the transistor, so I thought maybe we should try to fry the transistor. So I've wound the power supply up to its maximum, which is 30 volts with a 10 amp current limit. I'm a bit reluctant to even turn it on with my fingers anywhere near it, so I've got hold of this ground wire here, which I'm going to offer up to it. It's like offerings to the gods. And I'm going to turn the power supply on and we'll see if anything goes bang. Here we go. Yep. What went bang? Well, that's very interesting. Oh yeah, you got to see this. Hang on a minute, I'm going to turn the lights on. The little red clip has come off the end of the wire again. I think that's really interesting. So something's creating enough of a field, perhaps. I find this very unlikely. Let's try and watch this, see what happens. So I don't have the lights off because I want to actually see what's going on. So I'm going to put this little clip back on there. I don't believe this really, but I'm going to turn it back on. And we're frying away up at the top here. It's magic! And the clip jumped off. Well, flat out don't believe that, so we're gonna do that again, and then I'm going to spend the afternoon thinking about how the hell that happened. Well, that's just bizarre. Gets hold of ground wire so as not to get dead. Alright, you watching? It's on. There's lots of frying going on at the top. Okay. I just don't believe that. Yeah, I know what you're thinking. You're thinking, yeah, the clip's useless, it just fell off by itself. But it stayed on all day yesterday. Oh, it's actually getting a bit warm. Maybe that's what the problem is. How's the transistor doing? No death throes, no? What else is hot down here? Nothing. Alright, let's do that one more time because I just don't really believe that. So there we go, we got a okay. Well, just before we move on to doing the MOSFET driver version of this thing, I thought after the fiasco with the red power clip jumping off the other day that I would change the power clip. So this one is a new one and it's been sitting on here for quite a long time. Everything else is the same. It's the same NPN power transistor I pulled out of the old Marantz 150 watt amp. and I've got the same power supply driving it. We're going to wind that voltage up to 32 volts in a minute. 5 amps is the maximum current limit for this supply. And I'm going to go get a voltmeter which can measure temperature with a temperature probe and tape that to the heatsink so we can watch that while we power this thing up. And I've got the little piece of copper wire sitting on the top, so we'll be able to see if there are any corona discharges when we turn the lights out. So I brought in the multimeter, and I've got a little thermocouple which you can see is taped to the back of the heatsink so we can keep an eye on the temperature as the thing starts to run. And right now it's at 28 degrees C, which is room temperature here in steamy Florida. So I have a slightly larger flue tube today. I've got my ground wire here which I'm going to play with first. And I've got the power supply wound up to the max, so with some trepidation. Alright, we're frying. There's stuff frying down here which I'm not very happy about. Let's try the tube. Oh. Ow, that wire is actually hot on the end. Whoa, that was interesting. So this piece of wire, we can't see, it's gone dark, but this piece of wire at the end here was actually hot to the touch. Let's just do that one more time. So I'm very concerned about frying noises that I can hear that sound like they're coming out of my power supply. The multimeter's gone up to 35 degrees C, so it's gone up a couple of degrees. I've got a bigger fluorescent tube here. Well, there you go. Oh, ow! Oh, that gets very hot. So the piece of wire at the end here got really very hot, which I find very interesting, and burned my finger again. We've gone up to 35 degrees C here, which is not as hot as it got a few days ago when I was trying it, but it certainly works reasonably well. I'm very concerned about the fact that I can hear sizzling noises down in my power supply. I am now a bit dubious about how well grounded this is. It does actually have a 3-wire cord, but I'm not sure about that. And the 2-foot fluorescent tube that I bought the other day lights up beautifully. So I think we're in pretty good shape here to say thank you very much to this circuit, this Slayer circuit, and move on to a more complex design that drives a MOSFET with some square waves. Now, just one other thing. In the guest room where I have this set up, I have this little lamp here, and it's actually touch sensitive, and it was off like that until I turn the Tesla coil on, and then it turns on, and it's quite a long way from the Tesla coil. Should be interesting when we ramp the power up.